Welcome everyone to the MLOps Live webinar series, where we dive into the tools, practices, and strategies that help turn AI innovation into real-world impact. We're glad you're here and look forward to a session packed with practical insights. I'm Idit. I'm the head of community and open source marketing at Iguazio, an AI startup that was acquired by McKinsey back in 2023. Today, we're going to discuss orchestrating multi-agent workflows, a critical piece in building truly scalable and production-ready Gen AI systems. We'll explore how technologies like MCP and A2A are reshaping the way we build intelligent agentic systems. You'll learn how to overcome the challenges, improve system observability, and enable seamless collaboration between agents in complex AI pipelines. We're joined today by two fantastic speakers. We'll get started with Yaron Chaviv, the co-founder and CTO of Iguazio, where he will share his perspective on the shift towards agent-based architectures and what that means for enterprises adopting Gen AI. Then our fabulous guest, Mo, the VP of Customer Engineering at Google Cloud APAC, he will take us under the hood of MCP and A2A with a live demo showing us how these components work in practice to power multi-agents Gen AI workflows in production. And as always, we'll close out with a live Q&A. But before we begin, just a few housekeeping items that I want to share with you all today. This session will be recorded and a link will be shared afterwards. Don't worry, if you miss anything, we've got you covered. We'll also be taking questions throughout the session, which will be answered in the live Q&A at the end of the webinar, which is one of the highlights. Please drop your questions in the Q&A tab on the bottom of your screen, and we'll try to address as many as possible. We'll add two polls. We have two polls in today's session. Your input is really valuable in shaping future webinars, so we encourage you to participate. We'll also share the poll results live at the end of the webinar so you can see what everyone else answered. Lastly, we invite you to join our MLOps Live community to keep the conversation going after the session. We'll share the link in the chat now for easy access. And now, without further ado, I'm going to hand it over to Yaron to get us started.
Thanks, Idit, and welcome, Mo. And just before we dive into Mo's part, that will show us some Google innovation in the space, give you a brief on what is agentic AI and some of the challenges. So first, what is it? It's essentially autonomous systems made of AI agents of different sorts using foundation models and working in concert to provide the results. Why is it better than the previous tools instead of those rule-based tools and more strict systems? It can handle more complex workflows. It can generate better results, reduce the human intervention, and enhance productivity, and so on. But it does bring a lot of challenges, and some of those we'll discuss today. First, it is replacing a bunch of human processes, so there's always resistance for a change. There's a lot of more potentials for getting things wrong, like hallucinations, error, biases. There's no control. Those agents can run free, run loose, and now that we're talking about federated agent architectures where some of those agents are essentially someone else's or developed by someone else. How do you really control those? So it brings a lot of risks around security and government, and how do you trust those systems that start generating things by themselves? Maybe at a certain point they'll exclude us humans from the decision. So we need to have proper governance on all of those different things. So we have three generations as we see them. The first original, ChatGPT-like generation. We ask a question, we get an answer, most of it coming from the actual LLM information. And then we started adding all sorts of agents and RAG tools and so on that interface with external systems and have co-pilots or tools to interface with those other systems. So now we have a lot more knowledge. We can create actions, not just sort of answer questions. And those recent generation with agentic AI and multi-agents and reasoning and so on, we can build very complex workflows and start building systems that can replace human in certain tasks, can be much more sophisticated, avoid hallucinations, and so on. just to give you an example of an application from a use case we worked on. So these are the three generations. The first one, you're trying to ask a question. The system doesn't interface to those external services, is not capable of answering the question, and may even hallucinate and think it can answer the question. And then the next generation, so with RAG and so on, without reasoning, you can see you're getting better results, but it's still not too effective. It doesn't make suggestion. It's not as accurate all the time. And the last version with multi-agents and reasoning and so on, you could see you're getting something a lot more closer to a human interaction, a lot more productive. So these are the three generations that we want to get into. So, everything good has also sometimes bad or challenges, and those challenges will be overcome over time as the technology matures. So let's compare two scenarios. One is having a manual process with human handling all those different flows, and agentic AI, where those agents sort of communicate with each other and generate this workflow. So, the manual processes are always, take more resources and so on, versus agentic workflows that are more dynamic and fast and take less resources in terms of human resources. It is limited to manual processes are limited to the amount of resources we have. They're slow, where again agentic systems are much faster. On the other end, where we're looking at the caveats, humans, most of them you can trust them better. There's a compliance, there's processes, things are well established. Whereas in agentic systems, you have less trust over those components. So they can hallucinate, can run loose. They're vulnerable to various attacks. So some of them we don't even know. And lastly, all the aspects of accountability and so on. You can't punish a bot because it didn't produce the right result or cause a loss of money. So these are the challenges. And if we look at those three architectures, again, the first one, the user interacts with an LLM, and the second one is interacting with the services, not necessarily LLM, with an agent that uses LLM as sort of a co-processor for understanding language. And the final version is where you have all those different agents that communicate with sort of supervisor or control layer, generating the answer. Obviously, the last part, you can see for the same question, there's a lot more moving parts and questions and answers being processed. So it's obviously even slower and more expensive to produce the results compared to the other models. So we don't necessarily need to kill all the other models. We need to sometimes, when we need something simple, maybe the simple agent will do, and sometimes we may want to have a full reasoning system. Okay, so how does it work? Essentially, we need something that orchestrates the process to make the decisions, have sort of control the flows. We need tools to interact with external systems, whether it's RAGs or APIs to external services, or ability to browse the web and gather information, and so on. We have to process all the data, whether it's visual data, audio data, textual, and so on. And we need sort of a feedback loop to learn and improve. These are the main components of an agentic system. What are essentially the new things that we need beyond what we already had in traditional AI or using LLMs? We need the planning. We need explicit goal management. We need to know when the agent or the system produce the right results and with a good quality. We need those real-time perception and contextual awareness tools to understand, again, the entire process. We have memory in the system. One agent responds, the next one needs to take the response and pass it to another one. We need to augment the different results to a broader response. So all of those things require integration with short-term memory. We need orchestration of all of those different tools, and the topologies are becoming more and more complicated. Usually we had like DAG, like tree structures. You have a branch, you go left or right. With those systems, it's more of an orchestration, more of a collaboration of independent tools that talk to each other. So it's much harder to orchestrate. We need those specialized frameworks, and we'll talk about some of them. And we need much tighter monitoring, control, and governance, because those things sometimes run loose. So these are the key things that you need to consider when working on agentic AI. So this is a typical architecture of an agentic AI system. Obviously, we in McKinsey, we built a bunch of them for clients. On the underlying, you have the infrastructure, and there are different data resources for the entire lifecycle management of the application. Some of them are operational, like logs, monitoring, metadata configuration. Some of them are data used for the actual application, like vector databases, different tables, key value store, graph databases, and so on. And some are operational for the context of the application. For example, history of the session, the question, answer, and so on, managing the prompts in a more managed way, and so on. So this is the data layer. On top of we have a bunch of services or service orchestration, in many cases using Kubernetes or monitoring tools, observability. And we have those LLMs that may be in the cluster or some external service like OpenAI or Gemini. And then we have a workflow. This workflow is comprised of multiple steps. Some of those steps are not specific to the agentic AI, like authenticating the user request, doing pre-processing, post-processing of the content, some guardrails, but some of them are the application, the agentic workflow. And this agentic workflow is comprised of two different main elements, sort of agents and tools. Tools is something that, for example, interface into external system or does something specific like RAG. An agent is something that orchestrates those tools and operates them. You could see a bunch of agent examples, and Mo is going to dive deeper into notion of tools and agents and so on. But this is, again, a generalized architecture. And one of the things that we see emerging, which Mo is going to cover as well, is sort of the notion of decomposition. So we have the workflow, which is very application specific, or we may be able to even build workflows that are flexible enough to be used in multiple applications. But then we have resources that we want to access, whether these are LLMs or agents or tools or data resources. And we don't necessarily want to have all of those things in the same cluster. Maybe we even want someone else to build, develop, and manage those, maybe a cloud provider, or someone gives us a source code in a Git repository or even a ready-made container. So the general idea of those standards like MCP and A2A is the ability to decompose the architecture, which provides scalability, observability, better version control, and so on. So that's the general idea. And all those different services that we see here, again, there are three consumption modes. One is you just take a code, you add some packages and configuration, you build a container and you serve it, usually using serverless architecture. In our case, we use the Nucleo and MLRun for that. And there's another option of someone else built a container. Think about like NVIDIA NIM architecture, or there are a bunch of other examples of people providing you the fully sealed container that adheres to the protocol, MCP or A2A or others, or even OpenAI sort of LLM protocol. So you could just go deploy that container on your cluster. And the third option, the upper option, is essentially someone else build hosts, like OpenAI, Gemini, and so on, gives you a URL, and you just access that service externally. One of the nice things about this decomposition, you have a point that you can essentially slice with a knife and monitor and govern all this access. So you could see all the access to the LLMs using something like an LLM gateway. You can track all the access to tools, agents, data, and so on, and build better governance across those systems. One last slide, just some example of a project we built, leveraging MLRun and Nucleo, the underlying serverless engine. This is for one of the clients. Again, a full multi-agent system with agents and tools that work in concert to deliver the full application. The nice thing about those tools that we built is it provides full automation of anything from code to production at scale. All the monitoring is built in. There's a very efficient resource allocation, including GPU management. It interoperates with external services like the Google services that we'll just see now, so you can choose what you want to build by yourself and deploy, and what you want to leverage external services. And there's a large and emerging asset and component library that we can just go and deploy as part of the solution. So without further ado, let's move to the next part, to Mo and the poll question.
Yes, thank you so much, Yaron. That was fantastic. Before diving into Mo's section, bear with me. We would really love to hear from you guys. And without further ado, let's dive into Mo's section. I'll hand it over to you.
Thank you. Thank you so much, Yaron. And lovely to be here with everybody. And thanks everybody for joining. It's an absolute privilege to take a few moments here to dive into this very exciting topic of multi-agent orchestration. Now, one of the things to share in here is when we think about agents and multi-agents, as Yaron described, one of the things I've observed is we have to think about those in the context of the evolution. Agentic systems have really come to serve three major use cases. In the beginning, it was all about being able to chat with information, access it very quickly. Soon after that, we started to see that agents evolved to become a way to actually interact and interface with our data in a much better way, discover it, integrate with it, and actually start to understand how to get insights and recommendations out of that. And then, of course, as we evolved, we get into how do I actually automate some processes? This evolution that you see here mimics a lot of that. We, of course, start with an LLM and a prompt. Then you actually use RAG to retrieve some of those facts from data sources via things like search, and you stuff those into the prompt so that you can enrich the experience. And then at some point in time, a feature of some models called, function calling comes along and it allows these LLMs to figure out how and what and which APIs to call and what arguments and how to execute them. And then soon enough being just reflecting the speed in which we're seeing this evolution, you start to add reasoning loops to determine if we understand the user's intent. We review a plan, we figure out which tools we should use, and based on all of those dimensions, give even a better response. And now we essentially have agents speaking to each other because they have all the capabilities of RAG, tools, reasoning, and they can actually interface within their own systems until this point in which we now can have them talk to each other. This is now the stage in which we can fully start to realize full automation of certain workflows with the caveats that Yaron sort of described earlier. So if I was to summarize it, essentially, we are not just going to see, we are starting to see enterprise landscape evolve to be multi-vendor and multi-agent. Long gone are the days of just a single agent that might perform a single task or perform just a chatbot experience or go seek a piece of information. So the question for us is, how can we support this evolution? And if we think about it through the lens of an actual or just a very simple scenario, let's think of one where in a world of a multi-vendor, multi-agent, you're trying to create a simple travel agent experience that allows you to think from how do you actually go book the flight once you've searched the inventory, how do you actually go get the best hotel, how do you actually go and design certain activities, how do you actually go and get a guide that may help you during your trip. This sort of notion is a simple but realistic representation of everything that we've talked about with regards to multi-agent. Agents that can communicate with each other and agents that may be able to guide each other. If you peel underneath this, you start to realize that there are some very specific requirements that you need in order to be able to get those agents to communicate with each other. So first and foremost, these agents cannot just go look out for each other. There must be some way to discover, hey, I'm an agent. This is what I do. This is how you actually can communicate with me. And this is these specific tasks that I go and perform. Once I know what agents are capable for, they should be the ability for us to understand how does this agent communicate and what form do we want it to communicate from? Is it tasks? Is it text? Is it forms? Is it video? Is it audio? That modality becomes very important. Once we do that and we start to perform tasks between these agents, we need to start to be able to have a framework that supports or a protocol that supports the notion of giving status and updating each other, understanding if there are certain dependencies throughout the execution stage, until finally we get into the opportunity for them to actually collaborate with each other. So collaboration means anything from being able to invoke and execute on behalf of another agent, retrieve certain data, and so on and so forth. All of this is to simply say that for us to realize a world of a multi-agent, we cannot think of agents in the classical way of them just simply being APIs. Rather, they are much more sophisticated. They have to have context. They have to be able to understand. The prompt that you give them may actually require them to interface and interact with different systems in order to give you an answer. And hence, we see the birth of what we call the agent-to-agent protocol. This is something that we deeply thought about at Google when we were starting to use agents ourselves through Google Workspace or others. And we realized that there's all of these systems that you need to interface with, collaborate with, to serve a simple thing as give me a summary of a document or help me commit something into another place. This particular open protocol handles the dynamic and multimodal nature. So that's one of the key prerequisites of this type of a protocol. You have to start to understand within the protocol, how do you actually allow it to think around things like authentication and governance so that you can activate a particular agent within the framework that you have. It ought to be built on things that are standardized, such as HTTP, JSON, et cetera, so that we can leverage and reuse and enable the standardized protocols that we have. And then it only is as good as folks use this protocol such that these things can actually communicate seamlessly. For us at Google, this is actually incredibly similar, if you go back a little over a decade, to the beginning of container orchestration world, when we saw very quickly the opportunity for us to allow containers to communicate, the management of those containers, et cetera. And we went ahead through the community and created Kubernetes. And similar to what we did with Kubernetes, recognizing this last bullet, that it's only as good as the community participating, we went ahead and donated it to an open source foundation. So A2A is open source, and we had a number of founding partners that participated in this, ServiceNow, SAP, AWS, Cisco, et cetera, who all came in and helped define this protocol such that it meets both the needs of their enterprise systems as well as cloud providers and homegrown abilities for you to create these agents. And increasingly, we see a number of partners contributing to these agent-to-agent protocols. More recently, UiPath, for example, I was with them the other day. They announced their support for it. You have systems such as Atlassian, providers maybe who may be looking at building some bespoke and or homegrown. They can plug in their own agents into the framework. So that's the A2A as a first enabling and core capability that we require. So I have a standardized protocol. I can handle multimodality. I can understand how to shift the context. I can understand how to govern and who gets to invoke and or respond with some of these agents. I have a community that can contribute and govern into it. And I have folks that are adding actual agents that I can take advantage of. As Yaron said, not everything has to be built, but things that I could actually leverage and take advantage of. So that's A2A. How does it relate to MCP? Well, MCP is even more interesting because a lot of these agents, as I described earlier, they are really only as good as the data that they can interface with. And when you get into that particular notion of data, you quickly realize that MCP is designed for all the tools and the data sources that an agent needs to interface with, whereas A2A allows it to actually create the collaboration between the agents themselves. So if I look at the dynamic negotiation that happens from agent to agent, A2A helps these agents discover agents with agent card. They understand the capabilities. They understand whether these notions that I want to do this particular modality or the other. Whereas MCP allows us to start to think about what is that data source and consistently retrieve that information so that we can ensure that there is quality, there is repeatability in the sources of those. And of course, MCP interacts with things such as the agent development kits, etc., that allows us to facilitate access to a number of data sources. You can go into an AWS data store, you can go to a database, you can go to a GCP drive, and so on and so forth to be able to access these hardened tools. Those two capabilities combined are the foundational parameters from which we can build a multi-agent system. So now we have the necessary building blocks. The next natural question is, how do we actually allow folks to participate in this democratized notion of agents? So we don't create a closed environment where you can only use an agent provided by a single provider inside of their MCP server or using their own protocol. Well, it starts by understanding who are the users of these agents. There are business users who may want to be able to automate certain processes and don't want to at all involve any coding. And for those, it's simply building an agent and running it, and simply registering it for others to use with certain governance frameworks around it. For those, we use agent space as a framework to discover agents that are in place, to be able to invoke those agents, customize them as you need using the agent builder, all with no code, and then publishing them for the rest of the team to use it. You may be a business process owner, you may be an SAP administrator, you may be even somebody that may be handling, in that case of a travel agent, a part of the process that allows somebody to know which sort of backend system to go into. You simply put an agent that might allow you to understand which systems to connect into. Then there are folks who may want to take an existing agent and actually add a little bit more customization into it. So I would like the agent to actually go to 2 data sources and reason between them before they give an answer. For that, you have the agent development kit. You can start to build it. You can start to think around which sources it integrates with, using, of course, MCP, etc. You can think around allowing it to either seek human intervention or automatically go and execute a task. All of these characteristics you can define inside of the agent development kit, and then you deploy it and you govern it. In this instance, you can either do it in Cloud Run, the classical way, or you can use the agent engine, which takes care of a lot of the important things that Yaron described, like monitoring, logging, ensuring the state and consistency of the agent. So all of these operational elements are built into the agent engine, and you don't need to worry about it. If you have of course, your own custom needs, then you can deploy it in Code Run and use these custom tools that you have. And then finally, to Yaron's point earlier, maybe you don't want to build everything yourself, and there are some best practices. You might be seeking some sort of a crypto wallet capability, or you may be trying to get a particular agent that goes and does credit checks for you on behalf of financial services and so on and so forth. Well, those could be built using partners who develop those and publish them. And I'll talk a little bit about some of the partners that have worked with us on doing those. For us in Google, we use, of course, the agent marketplace, where you can go and discover a lot of these agents. And in a very simple SaaS fashion, you can click those, discover the agent card, and go and use them. And then finally, of course, once you start to use them, they go into the same sort of gallery of agents that are available for you and your developers to use. So that's one thing. Think about how we're democratizing it by actually allowing everybody to participate in the agent ecosystem, whether they are a coder or none. The second thing is, how do you actually make sure that this agent space is an open ecosystem? Now, of course, the underlying parameters of agent to agent and MCP are the underpinnings of that. But the framework itself should be agnostic by not only allowing, for example, one provider, in this case, in my case, it's Google, but you may be able, for example, to try and connect, as I said earlier, to a line graph, or you want to be able to use some other type of capability like Kukuaya. We see this all the time. The agent itself, or the gallery, should understand that you're interfacing and connecting and provide that seamless monitoring and integration into it, which is something that we do around the open ecosystem. So the platform itself must be open. Similarly, we should start to think about it when we think through the pro user around can I go and use some of the agent capabilities built out of the box? Not everyone needs to build a search engine. That's a sort of a core capability that you can build in everything. Allow me to actually access those facilities natively. Can I go and use agents that are built out of the platform? And can I use third-party engines? Now, can I customize them? And this is where the bottom two green boxes that you see in here become important. So as I start to think about customizing those agents, I want to start to think about the answers I'm getting. Can I connect those into better grounding? Can I create a learning loop and a cycle that allows me to understand what my agent is behaving and respond dynamically to the feedback of my user base? That this says the agent actually allowed me to do these things, but I would have wanted to improve the answers that I'm getting or the behavior in this way. Can I capture that and integrate it back into my development lifecycle? Those are the important things that you would build into the agent building as well as the model building capability. These things are not disconnected. Agents are talking to systems and they're leveraging models. And all of this is happening in a dynamic way. Can we actually simplify all of this as opposed to allow it? And that's where you create a very flexible platform that either uses what you have in your own house or uses third-party facilities. Last but not least, is this notion that I talked about, the marketplace. This is actually a roadmap item for us. We're currently trialing it. But when you create an agent, you may want to publish it for others to use. This could be simply for you to contribute and for others to leverage, or you can, of course, put it in a context of a monetization because you're delivering it as a service. We're working with a lot of customers, such as electronics manufacturers, services, providers like travel agents, etc., who are all creating these agents and putting them in the marketplace such that folks can use it. We have some agents that are actually experts in, for example, analyzing circuits and deciding whether those particular circuits have the right quality controls and so on, using vision models, etc., etc. So there's fascinating things that folks are actually building and putting into this marketplace. So this is it in a nutshell. Get the agent, the right protocol, get the connectivity in the data, use an open ecosystem that builds into it, create a flexible platform that allows you to decide at what layer do you want to use, consume, build, and customize agents, and then allow a facility for people to easily discover those. In the end of the day, this particular marketplace, which is an agentic economy that we see evolving, with these multi-agents communicating with each other, will depend on these protocols and what I just described around our ability to, of course, integrate these things seamlessly. But I believe that the best way to do all of this, Yaron, you talked about this a little bit earlier, is for us to actually show this to you. So Edith, maybe what I'm going to do is I'm actually going to take over the screen here, if you don't mind. And I'm going to go ahead and share my screen. And we're going to do a live demo. So if I can get a thumbs up from somebody that you can see my screen.
It looks great, Mo. Thanks.
Awesome. Perfect. So let me just start here by giving you a quick. This is actually Agent Space. We are in a live environment. If something goes wrong, I promise to re-record it and share it. And I also put it in debug mode. One of the things I want to describe, team, in this instance is I myself have a team, and this team works with customers every day. I was sharing this with Yaron. In the world of agents, everybody is trying to get access into prototyping very fast. And I actually have a small group of software engineers who do this. We work with a customer, we prototype something in production, we get going. And then we realize that the demand is surpassing our ability to actually meet everybody's needs. So we actually created a set of agents to mimic our software engineering team, such that we can automate some of the basic tasks. And in this particular environment, this particular demo that I'm going to show you, a simplified one, we're going to do a game that somebody wants us to actually go and build, and we inject a lot of human intervention into it. So you see my agents. I have a codesmith agent, which sort of is acting on my behalf, orchestrating the team. I have an agent such as Sarah, who's actually the product manager who analyzes the product requirements. And that's basically their agent card. I understand what their open modes are, what their output modes, how do they stream, how do they do the push notifications. I have Alex, who's, for example, generating the actual code. That's my developer. I have Ting, who is actually going to do all of the deployments and so on and so forth. While I'm doing the demo, we're going to be able to look at the logs and see how these agents are communicating with each other. So the first thing I'm going to do is, like everything else we typically get, we get a document that actually somebody has sent us to decide what the design of this particular solution is. So they send us this document, and I'm going to go ahead and prompt and actually simply say, please generate, an implementation plan and maybe a feasibility study. This is typically what the prototyping team is trying to do. So you can see the agent log. As I said, this is live, so I cannot guarantee the times it takes. Bear with me, Yaron. I will make sure we have enough time for Q&A. And what you see in here is that this particular agent, Codesmith, went ahead and said, hey, I studied the document, I interpreted, it's a game, it has a game controller, it has a UI, this is the stack, it has a game engine, it has some UI and a sound system and so on and so forth. Do you want me to approve and generate the code? And I'm gonna say yes. By doing so, and this is me injecting the human intervention, I could have told Codesmith to just go ahead and do that once it analyzes it. It passes it on to Alex. Alex is actually working on behalf of my coder, and they're actually generating all of that code. Now, in this particular instance, I could have asked Alex to go ahead and just simply proceed, or it's going to ask me to, hey, I understand that this is what I need to do. I'm going to go build this. Do you really want me to proceed? And I'm going to say yes. As I go ahead and try to deploy it, this is a moment where maybe I do not want to enable the system to fully have all of my credentials and so on and so forth. So in this particular demo, I went ahead and prompted them to seek my credentials before they go ahead. In a more realistic scenario, you might have integrated this with your own IAM systems, et cetera, and worked on them. So here it's requesting my user ID. I'm going to go and give that to it. Here we go again.
Nice GitHub handler here.
Thank you. Now it's going to come to me at some point. And oh, it's already come back from my password. Please, oh, I did mask it. Hopefully you don't have it. There we go. So already I have the credentials. I pass it. Do you want me to commit it? I say yes. It goes ahead. Yes, please proceed. Now, once everything has been committed and deployed, you notice that Agent Jim has found a number of issues in this. So there's a collision detected, 30 out of the thing, test cases did not fail. Do you want me to go and automate the fixing of those tests? And I'm going to say, yes, proceed. Again, it's doing all of that on my behalf. All of these have been applied. So do you want to go ahead? And I'm going to say, yes. Has been completed, the generation pipeline, please test out. So I'm going to go ahead and test this game. I cannot see your screens and votes, but I'm going to ask you to vote for me for a moment, because those who have seen this game know that I come from a generation where you can use only one thing to play a game. So let's start. I'll show you, and then we'll take bets. Oops, do you see? You missed it. That's how bad I am at playing games. Let's see how much do you think I'm going to be able to last? Let me restart it. One more time, Yaron, you think?
Yeah.
Let's try and beat the score. There you go. So now that I've done in here, it's going to say, I like it. I tested it. I'm going to go ahead and say, yes, please. Let's commit this code, and it goes ahead and it actually simply deploys the application. So if I go in here, team, and allow you to see what we've done, in this particular game, all what we have been able to simply show you is the ability for you to take an agent that has understood the document, another agent that actually went and committed the code, a third that actually goes and uses the cloud resources, and a fourth, which I did not show you, that integrates into a service now when we have a lot of these errors, that's been able to go ahead and commit, for example, a ticket. Now, a lot of these things have really meant that you can build games, or you can actually go ahead and build something more sophisticated. When you look at what we have done with Snap or Quora or Motorola, they've started to integrate all of these capabilities of chatting, getting better information with search, or actually getting agents to build all of these resources. I'll stop here, Yaron, because I know we would love to save some time for the questions. In the slides, you will get, dear audience, you'll have the chance to actually go and access a lot of these resources. And if you're interested to deep dive with us and the team, you can also register for these AI Agents Edition. We're going to go into a technical series where you can work with them. Let me hand it to you again, Yaron and team, for us to take the questions. Thank you.
Thanks, Mo. That was amazing. And hope next time you'll get more better results on the game.
I need to practice. You can tell I did not.
That was fantastic, Mo. Thank you so much. Again, to hear from you all, if you could take the moment and let us know what your challenges are with AI agents. Let's start off with Yaron, related to your section at the beginning when you were talking about all the different challenges. What are the top challenges that your customers face today when productizing agentic AI solutions?
It's a tough question. I think first need to really analyze and build a model of the application and essentially document the different aspects of the application first in order to then automate the process. The second challenge would be around the control layer, verifying that things are really acting according to plan. That may look good in a demo, but how do you make sure this thing works in production without potential risks? I think the last aspect is when people build something small, it's nice when you scale, starting to see costs piling up and sort of other challenges, latencies and so on. So thinking about the operational aspects during the design phase and not just after you finish the prototype.
Thanks, Yaron. Mo, you also had a lot of questions in your slides and also in your demo itself. Let's start with a lot of people asked about your use cases. If you could give some examples of the most popular use cases specifically for enterprises and also the industry, like what industries are you seeing adopting these strategies most?
Yeah, great question. I'll actually start with the easier part of that. With regards to industries, we've really seen this as a cross-industry. There's not been a particular industry that has not actually leveraged the agentic platforms and/or capabilities. The use cases really vary. Obviously, there is a very common one that we see with customer service portals, chats, and so on and so forth, where it's part of improving the customer experience. Agents can not just seek the information better and understand context and intent, but they also can actually go and automate some of these tasks there and thereabout without having to defer it to a later moment. So for example, you'll say something like, hey, can I, in the travel agent example I use, which we see, hey, instead of the classical transactional, do you want me to go and book it? You can also go and say, hey, do you want me to actually go and get a poll from your friends if this is a better hotel than the other things? That's actually one of the things that while you're talking with an agent to try and build a plan, it integrates with your own contact list and sends those things. Another one is in healthcare. We see this happening a lot. Healthcare is very ripe for automating, whether it's forms, understanding diagnostics, and so on and so forth. In public sector, one of our very popular use cases across the globe is helping teachers actually do grading, of schools and things like that. I can go on and on and on around the use cases, but they're not they're only limited by the imagination of those who are actually seeking it. My last one, Yaron and Edith and folks who are asking the question, was a very fascinating around Gen Media. You know, this is a space that has a lot of highly specialized manual intervention in the production process. And you can think we're shifting away from long movies and things into these 1-minute episodes. So how can I actually use agents to understand, decide where should I cut the episode, slice a whole scene and make it interesting? And we have some studios that are actually doing that to generate 200, 300, 400 1-minute episodes that usually would have taken them close to 6 months down into a week, using a lot of these agents that they built.
Thank you so much, Mo. That was great. And I know there's so many use cases and industries and examples that you can give, but for the sake of time, thank you for summarizing the top ones. Okay, here's a specific question for you, Mo. In A2A as well as MCP communication, how do you implement, I don't know how to pronounce this, RBAC, which is that role-based access control?
Yeah.
Okay, and specifically in a use case where the end user interface is available to all, but the data access should be governed based on the roles and responsibilities. I know that was fully loaded. Did you catch the question?
Yes, I indeed have. So, of course, RBAC has 2 parts to it. There is, well, actually, there's several parts of it. The same principle that we use in a classical RBAC can be implemented in an agentic system. They're not necessarily connected purely to an A2A or an MCP. They rather can be implemented at the agent level as well. So first and foremost, you have to do the classical inventory resources. So you need to understand what are the various APIs, et cetera, that you may be implementing and or connecting into from an MCP. You can create a registry of that and query it, so that you can actually go back against these resource pools and reverse the workflow that you have implemented. The second is you have to think through, if you are going to go ahead and start to do the rollback from a procedural point of view, you have to think about your organizational RBAC policies, and then you can actually implement an agent that designs that. So every time you commit a step of the agent, and we've seen do this, you would actually register that step with an RBAC agent that actually can roll back a lot of these things. If you commit a transaction, this is where it gets a little bit more nuanced and complicated. You may have to actually put some time-bound buffers to actually allow you to undo a particular transaction as the rollback happens. So it's just simply understanding how your processes and can you actually delegate that to an agent. If you start to think about the roles, one of the things that we also see very often, which is why in my demo, one of the questions was, why did the agent not just generate the code, commit it, and do all that? You absolutely could do that. But we did not necessarily feel comfortable. We actually inserted the role of this particular person should be in the loop, and they should actually be able to execute this and decide whether they want to roll it back in a test sort of cycle before it gets committed. So it's no different. The facilities are in there. You can delegate it to an agent, or you can actually code it directly into your agent logic itself. If you are interested, by the way, the session I described earlier, we go into a whole scenario where we commit a transaction and then we show you actually how you roll it back.
Yeah, any additional resources or anything that you want to share with us afterwards, Mo, please do so, and I'll share it with the audience.
Absolutely.
Thank you. Okay, Yaron, this is a question for you. So does McKinsey consult for best practice agent adoptions? Has products of already made agents or in the agent ecosystem? Where do you align with customers? I think that's just a question from your experience, how you consult for agent adoption and agentic AI.
So, McKinsey is a big company, so the answer is yes. And there are different teams that work on those different aspects. We work with clients on first, the infrastructure layer, which tools to use, also depending on the cloud of choice or on-prem and so on, building the practices, governance, and so on. We work with the clients on the actual identifying the use cases and taking the use cases and breaking it down to processes, and those processes to agents and so on. We We have several tools that we develop, including Iguazu tools like MLRun, Nucleo, and other overlay frameworks that work on top of it to do agentic AI, and also other tools developed by our colleagues in different Quantum Black teams. Like there's something called Agents at Scale, another set of tools that integrates with the different standards like MCP and A2A. So we do all of those different things. I'm sort of frequent flyer, so I do a lot of that with clients.
Yes, you are. All right, thank you so much for that. All right, we don't have so much time. I'm going to pick a few more questions. I think this is a really important topic to just highlight, Mo. How do I handle some security vulnerabilities with MCP? I see a few questions here that's talking about security and trust and vulnerability. So if you could expand a little bit on that, I think that would be really valuable.
Yeah, absolutely. This is another case where please do look at the materials I share with you, because I think that there is a rich amount of content that has been developed around that. And I think trust, safety have different dimensions to them, as well as security. So trust, of course, happens with us improving the quality of the LLM itself and reducing things such as hallucination, etc. And the simplest form of that is investing in grounding and grounding it with information that you trust. We have seen in the case of, for example, Snap, or the work that we did with Reddit and so on and so forth, the simple act of grounding reduced a lot of their error rates, and the trust in the information I'm getting down from about 60% or so to less than 8% over a cycle of time. The second thing is when you think around safety is a notion that is subjective down to companies and cultures and so on and so forth. And so the notion of having safety filters built into the platforms that you use become incredibly important. We've seen many people try to create their own safety filters, and it becomes a very big burden. So we've integrated it directly into things like the Vertex platform. The interesting thing is what might be okay in Korea, for example, may actually not be okay in another country, or vice versa. What might be okay for one company not. So part of this is also how to manage the understanding of safety, whether it comes to, for example, the generation of images or miners or things like that become very critical. Security is an interesting one. Today, the simplest form, and there's multiple dimensions, is we've now, when we work in enterprises, we've introduced the notion of a model armor right in front of that. And I describe that in detail right in front of the LLM. So when the agent is actually interfacing with an LLM, everything that you have with regards to scanning the prompt itself for any malicious activity happens at the model armor level. When it goes to the LLM, you're only passing it something that is safe. You're also understanding the credentials. You're also understanding if the equivalent of a DDoS is somebody actually spamming your prompts. All of that is built into technologies such as model armor. Those are the kind of notions that I would integrate into it.
Thank you very much. And we're going to end with one question, and for whoever, if both of you want to expand on this, we've seen a few people asking here about monitoring, and I think that's an important point to touch on. So how do you best monitor these agents? And from your experiences, what are some open source tools that you have used to monitor agents properly? Not sure which of you want to take that one.
Ron, you want to start?
Okay. I think we've developed things that are built into MLRun, and I also showed that this sort of decomposition that you're interfacing to LLM through another layer, or to the agent through another layer, allow you to gather all the information about the questions, answers, etc., into a log. And then there are different technologies to analyze that. For example, you can actually use other LLMs. That's something called LLM as a judge, to examine the question, the results, and even check, is this answer safe? Is this, or does this answer contain private data? So it's a very simple question you can ask on the answer, and then get something that gives you a quality level, binary yes no, or even a quantitative measure that you can drive into a dashboard. It is early days for agentic systems. There are a lot of questions still in place, like because it's sort of free running and free lose how to really control all those different aspects. I think there's still a lot of work in the industry to do. Mo, you can.
Yeah, no, I'll complement what you said, Yaron. Very well said. I've actually seen a wide range when it comes to the sort of tools that are out there. I've seen many of our customers work with things like LangFuse, Langsmith, MLflow. So there's a variety of them. It just depends what you are using relative to what you want to integrate with, all of those things. And some of them, of course, are extensible. Some folks have leveraged recent capabilities from classical New Relic or some other providers of traditional who have been able to expand. In the case of Google, as I described earlier, we actually built it in directly into the agent engine. So any particular agent that's been built in using agent and deployed, you can see anything from the behavior, the throttling, the protocols that are going back and forth. And if I had demonstrated this a little bit longer in the demo, you would see us actually be able to click in and look at some of the logs themselves. So it's really open there. There's open source. There's some built in with the provider. And then there are classical, application providers that are extending themselves to be able to integrate with a number of LLMs that you can plug your agents into.
Thank you both so much. Okay, before we end, I want to just make sure to keep my promise and share with everyone the poll results. So I'm just going to take a moment now to share the results with you from the first question. So we asked you all where you are in building your AI agents. 47% of you are experimenting with agents in the lab, haven't yet made that leap to production. 25% are planning to start building agents. 21% of you are just learning. And 11 have agents in production. And 4% have multi-agent systems live. So it's really great to see the mix here. And wish everyone the best of luck here that still have their agents in the lab to move over to production. We have a lot of content and sessions talking about how to do that. So I will share that in a few moments. The second question was about your challenges. And I know there are a lot of them. But we see here 48% of you can resonate or relate to the struggle of working in a production environment. That's not a surprise to me. 46% in data privacy, 44% in AI hallucinations, 30% in multi-agent communication, and 26% in cost. So thank you all for sharing with us your challenges and participating in both of our polls. So as we wrap up, I really would like to take a moment to invite you all to explore our website at aguazio.com. You'll find past webinar sessions along with a wealth of additional resources like blogs and case studies, best practices. We also want to hear your feedback as well if there's any content you'd like us to create. And I really just want to take a moment and say a really, really big thank you to Mo and Yaron for your excellent presentations, the live demo, all the resources that you shared with us. Really, really valuable and insightful and very practical. And a heartfelt thank you to all of you that took time, energy out of your day and participated with us today. We really look forward to seeing you again in our next session. And thank you all for joining, and thank you for speaking, Yaron and Mo.
Thank you. And thank you, Mo, for joining us and doing a wonderful presentation.
I really appreciate it. I'll just say that I needed a third poll, which is, do you think we should publish this game? Will you download it from the Play Store and use it? It is tough. We'll save that for next time. But Yaron, thank you so much for having me, and thank you for the wonderful questions.
Thank you all very much. Have a great day. Hope to see you on the next one.